In this video, we're going to talk about right triangles. When we classify triangles, we can classify them in three different ways. We can classify them as acute, where all of the angles are less than 90 degrees. We can classify them as right, where one of the angles is 90 degrees. Or we can classify them as obtuse, where one of the angles is greater than 90 degrees. In a right triangle, it has three different parts. It has the hypotenuse, which is directly across from the right angle, and then it has a leg and a leg. The legs are just not the hypotenuse. So the hypotenuse is specific, and then the legs are the other two sides. The Pythagorean theorem says the sum of the squares of the legs equals the square of the hypotenuse. So if we were to take the legs and make squares out of them, and so for example, this is side A and this is side B. If we take the area of the square, right, a square is just side squared, so A times A is A squared, B times B is B squared, then it would equal the square of the hypotenuse if we were to make a square here. So if this was C, C squared. So A squared plus B squared equals C squared. Here we want to classify each triangle as acute, obtuse, or right. So here we have these two lines here that mean they're congruent. Okay, that means this is an isosceles triangle. So these two angles are the same. Since this is 80 degrees, we know that a triangle is 180 degrees. So we're going to take 180 minus 80, which is 100. Since we know that these two are equal, that means we're going to take 100 divided by 2, and that's going to give us 50 degrees. 50 degrees right here. So that means that this is an acute triangle because all of the angles are less than 90 degrees. In this one right here, we have one angle that's 140. This means this is an isosceles triangle, right? That means these two angles are congruent. So if we take 180 minus 140, that's 40. If we take 40 and divide it by 2, it's going to give us 20. So we know these are 20 degrees. Okay, so we have two that are less than 90 and one that's more than 90. So this one is obtuse. In this one, we have a 90-degree angle. Okay, so this is a right triangle. That means this is the hypotenuse. These are the legs. This means these two sides are congruent, so their opposite angles are congruent. Since we know that this is 90, we're going to take 180 minus 90, which is 90. We're going to take 90 divided by 2, which is 45. The right triangle. For right triangle ABC, if AC equals 12 and CB equals 16, what is the length of AB? So right here, remember Pythagorean theorem says A squared plus B squared equals C squared. The hypotenuse has to be C, and then the other two can be A or B. So what we have here is A and B, and we're wanting to find C. So we would say 12 squared plus 16 squared equals C squared. 12 times 12 is 144. 16 times 16 is 256. That's going to equal C squared. So we add 256 to 144. That gives us 400. Then to find C squared, the opposite of squaring something is to take the square root. So we want to take the square root of both sides. So C equals 20. So side AB would equal 20 meters. Okay, this says if CB equals 10 and AB equals 25, what is the length of AC? So here's the hypotenuse. Remember, the hypotenuse has to be C. So now I have A or B right here, and then 25, which is C. So I want to find A. So I have A squared plus 10 squared equals 25 squared. So I have A squared plus 100 equals 625. Then I'm going to minus 100 from both sides and get A squared equals 525. Now, I want to take the square root of both of them. Take the square root of 525 and I get a equals 22.91287 and continue on. It says round to the nearest tenth, which is the number right after the decimal. So we want to look to the second number right here, the 1, and since it's less than 5, then we're going to keep this 9. So side AC is going to equal 22.9 centimeters. This one says if AB equals 20 and AC equals 5, what is the length of CB? So again, A squared plus B squared equals C squared. Okay, it doesn't matter. This can be A or B, just as long as the 20 is C. Okay, so we have A squared plus 5 squared equals 20 squared. I have A squared plus 25 equals 400. I'm going to minus 25 from both sides and get A squared equals 375. Then I want to take the square root of both of them. The square root of 375 is 19.3649 and continuing on. It just says round to the nearest tenth. So if I look here at this 6, it's 5 or greater, right? So that means I would round this 3 up to a 4. So that would be CB equals 19.4 inches. Now, these are special right triangles. They're commonly used triangles and they're multiple. So by memorizing them, it will help you save you a lot of time. Okay, one of them is a 3, 4, 5 triangle. If you see this 3, 4, 5, you know it's a right triangle. Okay, and then anything that's a multiple of it. So if we look here, 6, 8, 10, right? 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. Right? We could also do it, multiply it by 3, right? 3 times 3 is 9, so we could say 9, 5 times 3 is 15, 4 times 3 is 12. So we could say 9, 12, 15. In this one, it's a 5, 12, 13, okay, is another special right triangle. And there it's multiples, right? 5 times 3 is 15, 12 times 3 is 36, 13 times 3 is 39. And we could do that, multiply them times any of them. But these are ones that you're going to see quite often, so it's good to memorize these. To determine what the type of a triangle, to determine if it's right, you want to square all 3 of the sides. Add up the 2 smaller squares, and if it equals the largest square, then you know it's a right triangle. For an acute, the same thing, square all the sides and add the 2 smaller ones. If it's less than the largest square, then you know it's an acute. And for an obtuse, square all 3 sides, and if the 2 smaller ones are greater than the largest one, then you know that it's obtuse. For this one, it says, which of the following are Pythagorean triples? So this one just wants to know which one Pythagorean triples means which ones of these are right triangles. So what we want to do is take the 2 smallest squares. So for A, we want to say 7 squared plus 24 squared equals 25 squared. Okay, 7 times 7 is 49. 24 times 24 is 576. And 25 times 25 is 625. So if we take 576 plus 49, 625 equals 625. So that one is correct. For B, 2 times 2 is 4, plus 9 times 9 is 81, 10 times 10 is 100. So if we take 81 plus 4, that's going to give us 85. So if 85 does not equal 100, so this one is not right. For C, we want to take 8 times 8 is 64, 15 times 15 is 225, and 17 times 17 is 289. So if we take 225 plus 64, we would get 289 equals 289. So that one does work. For D, we have 4 times 4 is 16, 5 times 5 is 25, and 6 times 6 is 36. 25 plus 16, 25 plus 16 is 41, which does not equal 36, so this one does not work. For E, 6 times 6 is 36, 10 times 10 is 100, 12 times 12 is 144, so 136 does not equal 144, so this one does not work. For F, 5 times 5, we know this one already, right? 5, 12, 13, but we'll go ahead and go through it. 5 times 5 is 25, plus 12 times 12 is 144, 13 times 13 is 169, 25 plus 144 is 169, so that does work. For this one, it says, what is the length of the diagonal given the sides of a rectangle? We know that a rectangle has a right angle, so this would be a hypotenuse. So this is just a Pythagorean theorem right here. So we're going to say 10 squared plus 24 squared equals c squared. So 10 squared is 100, and then 24 times 24 is 576, and then equals c squared. So 576 plus 100 is 676. We want to take the square root of both of those. Square root of 676 is 26. So the length of this diagonal in the rectangle is 26. Now here we want to classify each triangle given its specific lengths. So take the two smaller ones, 4 and 10, okay, and we want to square those and add them together. Okay, 4 times 4 is 16, plus 10 times 10 is 100. Okay, 16 plus 100 is 116. Here it's 64. So since 116 is bigger than 64, this is an obtuse triangle. For this one, we're going to take 6 and 11. 6 times 6 is 36. 11 times 11, 11 times 11 is 121. And then we're going to add those together. So 121 plus 36 is 157. 13 times 13 is 169. So it's less than. That means this is an acute triangle. For this one, 12, 16, 20. Okay, we're going to take 12 times 12, which is 144. Then 16 times 16 is going to be 256. 20 times 20 is 400. If we take 256 plus 144, then that's going to give us 400. So since these equal each other, we know that this is a right triangle. And that is the end of right triangles.